that attack doesn't work. Unfortunately, then Christian went on to make the attack work again. And the way it works is, so in Tor, you can build your circuit one hop at a time. So you just say, now I have a 2-hop circuit, I'd like to extend this to a 3rd hop. And his approach is, I'd like to extend this to a 4th hop, and a 5th hop, and a 6th hop, and a 45th hop. So he builds this circuit that just goes all around the network. And Tor doesn't really know how to tell if somebody's doing that, because it just sees one hop at a time, and it just knows that somebody's sending packets back and forth. So first of all, this is a denial of service. It's a bandwidth magnification or amplification attack. The idea is that I send one cell, and I end up with 45 cells on the network. So with a cable modem, I can knock over a university-level Tor relay. But then it gets more exciting. Now I can build a loop with my circuit. Rather than just choosing arbitrary places, I choose the same 2 or 3 relays, and I just beat them up. I build my circuit over and over in a triangle. And that means that I can produce enough congestion that I can do this 2005 attack again. I can beat up those relays so much that now I'm able to detect if they're the ones that Alice is using or not. So the attack might work again. Pardon? Okay. So we fixed it. We made it so that Tor can tell if you're trying to build a path that's too long, and it cuts you off after 8 hops. So now the attack doesn't work anymore. But actually, then they fixed their attack. So the new version is you build your 7 or 8 hop path, which is all Tor lets you do, and then you exit from the Tor network to a Tor entry node. And then you run Tor inside Tor, and you build another 7 hops. And then you exit from that to another entry node. And then you run Tor inside Tor, and you build another 7 hops. And I don't have a good fix for that. So, yeah, we'll see how that one goes. So one answer is don't have Tor connect to each other. That works okay, except there are these things called open proxies, and you could just get a big list of them and use a new one as glue in between each circuit. There are also these things called bridge relays that I showed a few slides ago. We're intentionally trying to build a list of Tor relays that nobody knows the whole list of. So you should just get yourself a bridge relay and use that as glue in between each of these 7-hop circuits you're making. Then you can start looking at timing, and you can start saying, well, it took him a long time to extend that next hop, so come on, nobody takes that long, except somebody on a modem in Sudan who really does want to use Tor. So I don't have a good handle on that one. Another issue to worry about, and I'm running low on time, so I'll talk about it very briefly. So the question is, Tor changes its circuit every 10 minutes. And the reason for that is we don't want to put too many different web requests on the same circuit. Because when you use that circuit, you say, show me the front page of CNN, show me the page on astrophysics on Wikipedia, here's my Gmail login, and pretty quickly you're going to have said something that can identify you, and then all the other connections you made on that circuit are also identified to you. So the research question is, given a set of web requests that Alice wants to do, how do we allocate them over different circuits so that they're all separate, but we don't build too many circuits? And then another attack we need to worry about. Let's imagine, so Tor's directory system keeps you from spoofing the entire network. You can't lie about which relay you are because you're not going to have the private keys for the right relay. But let's say you connect to the first hop, and you say, please extend this to the second hop. And he says, oh, no, that guy's down. I can't reach him. And you say, okay, well, extend this to this hop then. And he says, oh, he's down too. After a while, you eventually pick one, and they say, oh, yeah, that guy works great. Here it is. You establish your next hop. So the attacker, and this works on the local network also, the local network can say, that node you can't reach, that node you can't reach, that node you can reach. Oh, yeah, you can reach that one. So this means that a local attacker can decide which relays you get to use. And how do we detect this? How do we automatically realize that the attack is going on? because there are a lot of other options. Maybe your network is down. Maybe you're in a really heavily firewalled place. Do we pop up a little warning in the GUI that says, warning, you might be being attacked, or maybe your network's down, or maybe you're in a restricted firewall place, or maybe you've got a slow connection, click OK. I don't have a better answer than that. Okay, so what's going to happen down the road? Traffic correlation is just going to get better. I can imagine some pretty innocuous sounding things. Let's say somebody publishes an MRTG graph of their relay. So now we have a very coarse graph of how much bandwidth it uses. And let's say somebody else publishes one too. Is the math good enough and efficient enough to take those two graphs and match them up? That would suck, because a lot of ISPs publish that sort of thing too. So how good can we make these correlation attacks? A bunch of more people, more countries, more companies are probably going to start blocking the Tor network. China blocked the Tor website during the Olympics, and they probably are never going to unblock it. So the arms race for Tor bridges is going to start at some point, hopefully not for a while yet. Nobody has blocked the Tor network right now. There are no countries where Tor does not work. And then there's data retention. Nobody really knows quite what the law that you guys have means. The summary, as I understand it, is that service providers, whatever that means, have to log stuff, whatever that means. I've heard from one person who says it means that major ISPs need to remember the IP address that they gave their customers. Okay, that doesn't sound so bad. I've heard from some other people that every person who has a computer has to write down every TCP header for every packet they see forever. That sounds pretty bad. Where's the balance? So the German Privacy Foundation people have talked to a lawyer, and the lawyer gave them a legal opinion that said, it says here service provider, and it actually says service provider who's making money. So if you're not making money, then you're not a service provider, so you don't have to log. That would be nice. I hear that FOBUD has put in a claim against the Constitutional Court to try to say that this is a crazy law and it doesn't actually match any of the other laws that we should have and you should throw it out. They're actually holding a workshop right after this downstairs in workshop room A03 to discuss it a lot more. So if you're a German relay operator, or you'd like to be one, or you have ever thought of being one, or you're not in Germany but you're interested, you should go to room A03 after this and learn more. So I actually talked to a bunch of police in Stuttgart last year after Congress. I flew down there and gave a talk to about 40 detectives and law enforcement officers to try to teach them how Tor works and how internet crime works and get them up to speed on technology. And one of the interesting things that they told me, I was talking to them about this data retention law and what does it mean and why does it exist and what are you planning to do with it? And they said, we didn't ask for that law. We went to the legislators and we said, can you get them to answer, can you get the ISPs to answer their mail? Because they don't answer their mail right now. And ideally, can you get the ISPs to answer their mail on weekends too? That's what they asked for. And boy, did they not get that law. They got something very different. And they don't want the law that they got, or at least the people I talked to didn't want it. But they really do want the ISPs to answer their mail, ideally on weekends too. So they're not going to argue against the law. They need something. So they basically told me that they're relying on CCC and FOBUD and other groups to make the law go away because politically they can't argue against it. So that's an interesting approach. So there are a couple of modifications we can do. If it turns out that data retention means that ISPs remember TCP headers, and I'm pretty sure it doesn't mean that yet, so let's not get ahead of ourselves, but if you guys are crazy enough to pass another law in a few years that says everybody must write down everything they see on the internet, we have a couple of design modifications on Tor that should make it a little bit more robust against that. The first one is you never have an entry node inside Germany. And that means that everybody who's using Tor from outside Germany is never going to be noticeable by a German ISP. Nobody's ever going to see that first hop. And everybody who's using Tor inside Germany is going to go outside first, so they're never going to interact with a known Tor server first. And if they want to be really paranoid, they should use bridges, and that way they never interact with anything that people are able to keep track of. We don't need to go that far yet, but we'll see. Another key point, we're not going to put logging into Tor. There are a lot of people who come up to me and say, I really want to obey what I think the new German law means. Can you please put a backdoor in my software? I want to help out. We're never going to put logging into Tor. And the other point, is CCC is going to challenge this law also. They've been talking to various lawyers about the most effective way to do this. And we've been chatting with them also. And the CCC Tor bank account that I talked about last year and that you can find on our donate page and you can find on all of these fine flyers that you have outside, we're going to put all the money that's gone into that account over the past year towards their legal fees for finding a good lawyer and taking down the law. So if you want to put in more money over the next while, it will be put to good use. Okay, so a couple of last thoughts. One of them, pretty much any bug that we find, any sort of, I think this is a denial of service, I think this might be a problem, could be a crash bug, pretty much all of them turn into anonymity problems if you're creative enough. So one of the challenges here is that every time we slip up in any way, if we think hard enough, we can say, hey, couldn't you break anonymity with that too? So it's tricky to do any sort of design modifications because you have to think about all the different issues. Another point, a lot of the hard problems that I've been talking about today, the congestion attacks and the latency and stuff like that, those apply to all the other systems out there also. So I'm not saying Tor is broken by these attacks, go use something else. I'm saying low latency anonymity attacks are potentially broken by these attacks. Consider the attacks if you really need low latency anonymity systems. It's a little bit tricky because when Tor starts, we have a little warning that pops up saying, this is still experimental software, don't use it if you really need good anonymity. And I still have a journalist every few months who writes up a little article saying, the Tor developers don't think Tor is ready for prime time yet. They recommend you use something else for now. No, we don't recommend you use something else for now. Tor is the best that we know about, but it's still not good enough. And then the last point, people find these things because we have a specification, because we are open and thorough and try to explain everything. That's why we have to show up and say, here are all the attacks we know about. First of all, you should know about them. And second of all, please help us fix them. And hopefully, we'd love to hear from you if you have any more attacks or defenses or you find any problems with Tor. Every so often, there's a new group that puts out a new project based on Tor, and they never think to send us mail first. And that means that we don't ever see it until it goes out, and then we send them mail and say, hey, I think you have a huge security problem right here. And if they're good people, then they say, oh man, you're right, I should fix it. And if they're bad people, they say, well, we already have a lot of money invested in this, and security doesn't matter that much, so we're just going to keep doing it. So we'd love to hear from you before you make that sort of mistake. So thank you.
We have 2 minutes for a question. Yeah? Can the mic go?
Okay. So I've got one good and one bad news for you. One of them is the network map you talked about. Well, it actually does exist. It's something that moves around, so it's dynamic, but it does exist. I've got a researcher just next door my office who's doing this. And the good news is that you can actually use the same technique that phishers or malicious people use to hide their servers behind fast foxing. I don't know if you've heard about it.
Yep.
Well, you could use that to do the Alice and to actually route people behind blocked block countries to Alice, and Alice would be fast fluxed. Ooh, this is a bit difficult word to pronounce. Anyway, so would be fast fluxed through to the Tor network, and this network